You are inside something. Not a room, not a planet, not a solar system, or even the observable universe in the conventional sense. Something larger than all of those. Something with a boundary you cannot see, cannot reach, and cannot escape. Not because the distance is too great, but because the physics of what you are inside prevents escape by definition. This is not a metaphor. This is not a thought experiment designed to make you feel small. This is a hypothesis, a serious, mathematically grounded, peer-reviewed scientific hypothesis that has been developed by physicists at some of the world's leading research institutions and that has not been ruled out by any observation we have ever made. The hypothesis is this: the universe we live in, everything we can see, everything we can measure, everything that has ever existed in the 14 billion years since the Big Bang, may be the interior of a black hole that formed inside a larger universe we will never observe and cannot reach. We are not falling into a black hole. We are not near a black hole. We may be, in the most literal physical sense, inside one. And the reason this hypothesis exists, the reason serious physicists take it seriously rather than dismissing it immediately, is that the mathematics of our universe and the mathematics of black holes have no business being as similar as they are. Start with what a black hole actually is. Not the popular image, the dark sphere surrounded by a glowing ring, the image from M87 that appeared on every front page in 2019. The physical reality underneath that image. A black hole forms when mass is compressed into a region small enough that the escape velocity, the speed required to escape its gravitational pull, exceeds the speed of light. Once that threshold is crossed, nothing inside can get out. Not matter, not light, not information of any kind. The boundary where escape becomes impossible is called the event horizon. The event horizon is not a physical surface. It has no texture, no temperature, no material reality you could detect if you crossed it. It is a mathematical boundary, a point of no return defined entirely by geometry and the speed of light. Cross it traveling inward and you would not feel anything unusual in that moment. You would simply be inside. And here is the detail that matters for everything that follows. In 1922, mathematician Alexander Friedmann derived solutions to Einstein's field equations that described a universe that was not static, a universe that expanded or contracted over time. Those solutions formed the mathematical foundation of modern cosmology. The expanding universe, the Big Bang, the large-scale structure of space-time, all of it rests on Friedmann's equations. Those equations have a feature that took decades to fully appreciate. They are formally identical to the equations describing the interior of a black hole. The mathematics that describes space expanding outward in every direction from every point, the mathematics that describes the universe we live in, is the same mathematics that describes the interior of a Schwarzschild black hole, with the direction of time and the direction of space exchanged. This is not a loose analogy. It is not a poetic similarity. It is a precise mathematical equivalence. The Friedmann equations and the interior Schwarzschild solution are related by a coordinate transformation, a remapping of variables that converts one into the other without changing the physics. What this means is that there is no mathematical test you could perform on the universe from the inside that would distinguish it from the interior of a black hole. None. The physicist Lee Smolin took this mathematical similarity seriously and built a hypothesis around it in the 1990s called Cosmological Natural Selection. His reasoning started from a simple observation. Every black hole that forms in our universe, every stellar collapse, every neutron-star merger, every supermassive black hole at the center of every galaxy creates a singularity, a point where the known laws of physics break down,
a point where the equations stop working. What happens at a singularity is unknown. Physics as we understand it cannot describe it. The equations produce infinities, and infinities in physics are generally signals that the theory has reached its limits, not that something genuinely infinite is occurring. Smolin proposed that at the singularity, rather than physics simply ending, a new region of space-time is created, a new universe, born from the singularity expanding outward on the other side of what we can observe and cannot ever reach. The event horizon of that parent black hole, the boundary within which our entire universe exists, is not somewhere in the observable sky. It is not a wall we might one day approach. It is the outer boundary of our space-time itself. It is what the universe is contained within. And nothing inside can cross it outward by definition, because that is what an event horizon means. But here is where the hypothesis becomes more than mathematical speculation. If Smolin's picture is correct, if universes are born from black holes and each new universe inherits slightly modified physical laws from its parent, then the universes that produce the most black holes have the most offspring. The universes that produce the most offspring dominate the population of universes over cosmic time. This is natural selection, literally, applied to universes. The question it generates is both simple and vertigo-inducing. What physical laws maximize black hole production? Stars that are massive enough to collapse into black holes rather than white dwarfs or neutron stars. Sufficient carbon for complex chemistry to allow those stars to form. A cosmological constant small enough that the universe expands slowly enough for stars to form before everything disperses. Nuclear force strength that allows stable atoms and therefore stable stars. In other words, physical laws very similar to ours.
The physical constants of our universe. The values that physicists measure but cannot derive from first principles. The numbers that seem fine-tuned in ways that strike everyone who examines them closely as suspicious, are, under Smolin's hypothesis, not fine-tuned by design. They are the result of selection pressure. Universes with our constants produce many black holes, and therefore many offspring universes. Universes with very different constants produce fewer black holes and fewer offspring. Our constants dominate, not because they were chosen, but because they were selected for, across generations of universes, by the same blind process that selects for traits in biological populations. The universe looks designed, because universes that look designed produce more offspring. Now here is the part that is genuinely difficult to sit with. We cannot test this directly. The parent universe, the larger space-time in which the black hole that became our universe formed, is causally disconnected from us. No signal can cross an event horizon outward. No observation we make can reach beyond the boundary of our space-time. We are sealed inside. But the hypothesis makes predictions about our universe that are, in principle, testable. If our universe was optimized by selection for black hole production, then the physical constants should be near optimal for that purpose. Change them slightly, and you should get fewer black holes, not more. Smolin has identified specific predictions, specific ways the constants would need to be adjusted if the hypothesis is correct, and some of them have been tested with current observations. The results are mixed. Some predictions hold. Some are in tension with observations. The hypothesis is not confirmed, but it is also not ruled out. It exists in that uncomfortable middle space that the best scientific ideas sometimes occupy. Too coherent to dismiss, too incomplete to accept, waiting for the observation or the mathematical insight that will push it clearly to one side or the other. There is a separate line of reasoning, independent of Smolin, that arrives at a similar place. In 2010, physicist Nikodem Poplavsky published a paper proposing that the Big Bang itself
could be explained as the formation of our universe inside a black hole in a parent spacetime, using a framework called Einstein-Cartan theory, an extension of general relativity that incorporates the quantum mechanical property of spin into the geometry of spacetime. In Poplavsky's model, when a black hole forms and matter collapses inward, the spin of the particles involved creates a repulsive force at extreme densities that prevents a true singularity from forming. Instead, the collapse bounces. The infalling matter reaches a maximum density and then rebounds, expanding outward into a new region of spacetime that is causally disconnected from the exterior. From outside, it looks like a black hole. From inside, it looks like a Big Bang. Our Big Bang in this model was the interior of someone else's black hole. Every black hole in our universe is the exterior of someone else's Big Bang. Right now, wherever a massive star is collapsing in any galaxy in the observable universe, a new space-time region is inflating on the other side of the forming event horizon. New universes, born continuously from every black hole in every galaxy across the entire observable cosmos. We cannot see them. They cannot see us. The physics that prevents crossing an event horizon outward applies in both directions. They are sealed inside their universes as we are inside ours. Go outside on a clear night. Find a galaxy in the sky. Andromeda is visible to the naked eye from a dark site, a faint smudge just below the Andromeda constellation, 2.5 million light-years away. Inside that galaxy, stars are dying. Massive stars are collapsing. Black holes are forming. Each one, if Poplavsky's model is correct, is the birth event of a new universe that will expand for billions of years inside its event horizon, develop its own stars and galaxies and black holes, and never know that the universe it was born from exists. There are 2 trillion galaxies in the observable universe. Each contains hundreds of billions of stars. Many of those stars will end in black holes. The rate of black hole formation across the observable universe is millions of events per second. Millions of possible universes per second. And our universe, this one, the one you have lived your entire life inside, was, if this hypothesis is correct, one such event. A collapse somewhere. A singularity that bounced. A new space-time that inflated outward, cooled, formed hydrogen, formed stars, formed galaxies, formed the conditions for chemistry and biology and the entire 14 billion year sequence of events that produced this moment. Inside a black hole, expanding within an event horizon that constitutes the absolute outer boundary of everything we can ever know. There is no way to confirm this from where we stand. That is not a temporary limitation waiting for a better telescope or a faster computer. It is a fundamental consequence of the physics involved. The event horizon of the parent black hole is not a distant object we might one day observe. It is the outer edge of space-time itself, the boundary within which all possible observations occur, by definition. We are not looking at the wall from the inside. We are the inside. Every measurement ever made, every photon ever detected, every gravitational wave ever registered, every particle ever accelerated and collided and analyzed in every laboratory in human history. All of it, if this hypothesis is correct, happened inside a black hole. Not trapped in any dramatic sense, not compressed, not falling toward anything, just inside. The way everything is inside something, all the way down.